The objective of this experiment is to use linear air track to investigate Newton's law of motion.
Introduction of experimentary linear motion. Newton's equation of motion for a point of mass m to which a force F is applied given by the following, which is F equal to ma. The two masses will have acceleration of the same magnitude because they are connected as a single system by unstretchable massless string. Now shown by figure 2a, there are three forces acting on M2. Frictionless surface pushing out on M2 labeled T, which is tension. The contact normal force and the gravitational force cancel each other, meaning the total force acting on along vertical direction on M2 is equal to 0. Newton's second law said that M2 will accelerate and give the equation which is 2 equal to ma. Notice that tension has been eliminated from the final equation and is not needed in the analysis since we are only concerned with force acting on the system, not acting between objects within the system.
For the apparatus, we are using falling sphere apparatus consisting of release unit, impact switch, digital counter, 4 decades, support base, right angle clamp, plate holder, meter scale, support rod, connecting cord and ball bearing.
So this is the procedure that you need to do for the experiment. I will show to you how the experiment going from a tree perspective. Okay, so
I will explain the results of linear motion experiment. First, as we can see, we have length of flag and mass of hanger. In table 4.1, our experimental data include of total of slotted masses on hanger and time taken t square, and to get the average, we have to add t1 square and t2 square, then divide by 2. Next, to get square of time taken, we need to square t1, so we get 0.048. For total mass of hanger and slotted masses, we need m1 plus m2, which means 0.0103 plus 0.2, so we get 0.0303. Then for weight of hanger and slotted masses, we take 0.0303 multiplied with gravity, which is 9.81, so we get 0.297. The last one for acceleration, 2 multiplied with 0.1 divided with t squared. So that's all for the results.
Next, I'm going to talk about the analysis. So as you can see, we got a linear graph here after we have done plotting all the graph. After I plot the graph, I find the gradient by using the gradient formula y2 minus y1 divided x2 minus x1. In this calculation, the y2 is 1.0, so 1.0 minus 0.5 divide 14 minus 7. So I got 0.07 meter per second, power of negative 2.
Newton's second law states that the acceleration of an object is directly related to the net force and inversely related to its mass. Acceleration of an object depends on two things, which is force and mass. From the plot graph, the results show that the total force of both graphs is directly proportional with the acceleration of the object of both graphs. From the plot graph, we can see the graph relationship between the total force with the acceleration of the object is related with the Newton's second law of motion, which is Fma. When the force is increasing, the acceleration is increasing. If this experiment is conducted in real life, experimental error will occur because of random error or systematic error. One of the errors that is possible to occur is air resistance. It will affect the acceleration of the object that result in different acceleration in this experiment.
To sum up, in this experiment, we use linear air track to investigate Newton's second law of motion.